All right, so welcome to lesson number 9. Unfortunately, I had a couple meetings today, and some of my classes were not going to see this whole lesson from me. So I decided to make a video for the whole lesson. This way, if there were anything that you missed, or if I was gone for a section of the period, you were able to catch up, and we could kind of keep chugging along and keep going. So the opening exercise asks us to find the measure of angle ABC. Angle ABC is this entire angle here. Notice there are 3 lines that are all parallel to each other. So if I take a look just at the top 2, I see alternate interior angles, which allows me to say that little angle there is 75. If I just look at the bottom 2, well, that tells me that this angle is 45. Well, if I look at angle ABC, then is the sum of those 2 smaller angles, 75 and 45. So that tells me that angle ABC is whatever that adds up to. So that'd be 120 degrees. Number 2, well, it gives us these 3 angles, angle 1, angle 2, and angle 3. If I look, angles 1 and 3 are congruent because they're going to be considered corresponding angles. Angle 1 could also be congruent to this angle here, which has no angle label, but those are vertical angles. And then these are also corresponding from the other set of parallel lines. So essentially, angles 1, 2, and 3 are all the same size. So if they're all the same size, that means I could take any 2 of them and set them equal. Now I'm choosing angles 1 and 3 because they both have the variable x. And that's one of the things I need to solve. I don't want to have an equation that has x's and y's in it. That just becomes confusing. So if I make my equation 16x minus 8 is equal to 14x plus 2, well, then I can go and subtract 14x, giving me 2x minus 8 equals 2. Add 8, give me 2x equals 10, divide by 2, or x equals 5. So now I know the x value. Once I know the x value, I can plug into one of these 3 angles. Doesn't matter which one. So I'm going to choose angle 1, plug in the 5, and subtract the 8. So if I do that, I wind up getting an angle there of 72 degrees. So what that tells me is, well, not only is angle 1 72 degrees, but all 3 of these angles are 72 degrees, including angle 2. So that means I could say 72 is equal to 4 times y plus 8. Now from here we could do a couple things. We could distribute the 4, or the easier way, which would be divide away the 4. That's going to give us 18 equals y plus 8, subtract 8, and now I have 10 equals y. So now I've done what they asked me to do. I found x and I found y. All right, so that's the opening exercise. We should have been able to do those 2 questions with the knowledge that we had from the previous few lessons. So let's jump into today's lesson. Today's lesson is essentially an extension of what we did with parallel lines and transversals. It's something called auxiliary lines. Auxiliary lines are basically just lines drawn in a diagram that are parallel to lines in the diagram. So in this picture, my auxiliary line is going to be here. And I'm going to put it through that point where these 2 transversals kind of intersect or change direction. And then if I go through and label this, some of these angles here, so let's label this angle 1, 2, 3, and 4. There are 3 statements that we can actually make here about those 4 angles. I know angle 1 is equal or congruent to angle 2. I know angle 3 is congruent to angle 4, and I know that if I add angle 1 and angle 4, it's going to be the same thing as if I add angle 2 to angle 3. So there's a lot of things that are going to go on here that kind of can help us solve for missing angles in a picture that looks like this. So let's jump right into one. So if I have this diagram, I can extend these two parallel lines and I can draw in my auxiliary line. Now, if I just look at the two top lines, I see this 144 and this part of angle 1, they're on the same side of the transversal. That means they're supplements to each other. Alright, so because that part of angle 1 and the 144 are on the same side of the transversal, if I do 180 minus 144, that gives me 36. So that means this angle here is 36. If I look at the auxiliary line and the bottom parallel line, well, I see these two angles are alternate interior, so I know that this angle is 56. Therefore, angle 1 is 36 plus 56. That means that angle 1 is 92 degrees. Let's look at number 2. Number 2 is a little bit more challenging only because they're giving you the angle in the middle and asking you to find one of the angles that's not in the middle. So that's 35 degrees. I know this angle is 35 because of vertical angles. I know if I draw in my auxiliary line here, this angle becomes 35. And if the angle in the middle is 72 and part of it's 35, that means the other angle is 37. If that angle is 37, I know the alternate interior angle is 37. And an angle 2, well, that's vertical to 37, so that angle is 37 as well. All right, so that's basically auxiliary lines. Now, the thing with auxiliary lines is you're never going to see a question that says draw the auxiliary line. You're just going to need to know to do that. All right, so the pictures all look the same, so that's kind of a little hint for you. Let's look at something that I'm hoping you remember from middle school. Angle A plus angle B plus angle C of a triangle equals 180. We've actually even seen this in previous lessons. We've used this concept already, right? We'll even dive more into it in lesson 10. But we'll try some of these questions with some parallel lines and things like that today. So let's look at number 1. So right away I see these two angles are a linear pair. So if I take 180 and subtract 78, I get 102. So this angle is 102. Now I know that the triangle has to add up to 180, so if I take 180, subtract 42, and subtract 102, whatever's left over from that subtraction is going to be angle 1, so that's 36. So now I know angle 1 is 36 degrees. Number 2, I see parallel lines. Parallel lines are important because parallel lines give us alternate interior angles. They give us a lot of things to look at there. So in this picture, I see this 57 degrees is an alternate interior angle to this angle, so that makes this 57 degrees. I see a linear pair here, so that means this angle is 86 degrees. And then I can take 180 minus 57 minus 86 and see what that gives me. All right, so that gives me 37, so that means this angle here is 37 degrees. Well, if I take a look at these two, well, those are a linear pair as well, so if I take 180 minus 37, that gives me 143 degrees. So there's angle 2. Angle 2 is 143 degrees. Sorry, my pen isn't really working great right now. I don't know why. All right, let's look at 3. 3 we have to do an auxiliary line here, kind of. So we're drawing one here. One of the things that I don't want you to get confused about is an auxiliary line does not bisect the angle. I'll say that again. The auxiliary line does not bisect the angle. So that 94 is not being split evenly. But I do know that I see some vertical angles here and here. So this angle down on the bottom is 46. Well, that angle is 46. If I subtract 94 minus 46, that gives me this angle of 48. Then, if we look, we have alternate interior angles here and here. All right, alternate interior angles we know are equal, so I know that angle 3 is 46 and angle 4 is 48. Look at that, not too bad. Number 4, we have to see that there are multiple triangles in this picture. So this is a triangle, meaning those 3 angles have to add up to 180. So if I take 180, subtract 68, and subtract 58, whatever is left is angle 5. So if I do 180 minus 68 minus 58, I get 54. So that means angle 5 is 54. Angle 6 is a little bit more challenging to figure out. So I see a linear pair here. So if I do 180 minus 68, I get 112 for this angle here. I see 3 angles that make a straight line. So if I do 180 minus 93 minus 58, that gives me this little angle is 29. So if I take 180, subtract the 112, and subtract the 29, whatever is left winds up giving me an angle of angle 6. All right, so if we subtract those out, let's see what we get. So 180 minus 112 minus 29, that gives us 39. So that means angle 6, well, that's 39 degrees. All right, the last thing we're doing in this lesson is we're looking at a little bit more algebra involved with this. One of the things that you learned in algebra is how to make let statements and determine things in a word problem, essentially. So let's take a look at 5. 5 is kind of a straightforward one. This is one that we hope is on the Regents exam. So this gives us 3 angles of a triangle and asks us to find the value of x. I know each of those 3 angles has to have a sum of 180. So I know that x plus 3x plus 5x minus 54 is going to equal 180. Combined are like terms. So I have 9x minus 54 equals 180. Add 54. And I have 9x equals 234. Divide by 9. And whatever that comes out to be is our answer. So x is 26. One thing to look for, what does it ask you to solve for? It asks you to find the value of x, so that's what we're going to do. That one wasn't too bad. 6 is where things start to get a little bit more challenging. So it says the measure of angle B is 21 less than 4 times the measure of angle A. That's describing angle B. It then says that angle C is 1 more than 5 times the measure of angle A. That's describing angle C. So the only thing we don't know is angle A. So I'm going to let angle A just equal variable A. Angle B, well, that says 21 less than 4 times A, so that's 4A minus 21. And angle C, well, that says 1 more than 5 times A, so that's 5A's plus 1. We should remember how to set those up at least from Algebra 1. Once I know the 3 angles, I then can plug in to an equation. A plus 4A minus 21 plus 5A plus 1, and that's all equal to 180. Combine like terms, 10A minus 20 equals 180. Add 20. 10A equals 200. Divide by 10, and I have A equals 20. If A is 20, that means angle A is 20. Angle B, well, that's going to be 4 times 20 minus 21. So that's going to be 59 degrees. I'm just plugging into here, so this would be 4 times 20 minus 21. Same thing for angle C. So angle C is going to be 5 times 20 plus 1, so that's going to be 101. Nice easy check is those three angles should add up to 180, and they do. Number 7 would be probably as difficult as I would make a question. So it gives us the three angles of a triangle. Notice one of them has the expression x squared. So that means it's probably going to come out to be quadratic, which is going to require us to remember some algebra from last year. So first thing I want to do is I want to take our three angles and add them up. So x squared minus 6x plus 100 plus x plus 56 equals 180. Combine like terms. X squared minus 5x plus 156 equals 180. All right, that's great, but now we have to see, this is a quadratic. Now there are three ways of solving a quadratic. We can factor to solve, we could do the quadratic formula, or we could do completing the square. For this class, most of the time we're going to be able to use factoring to do this. Any of these methods you want to be equal to 0 first for. So I'm going to subtract 180. So I have x squared minus 5x minus, what do we got there? 24 equals 0. Then I'm making two parentheses. I'm saying, what multiplies by itself to make x squared? Well, that's x. What multiplies to make negative 24? What adds to make 5? Well, that's negative 8 and positive 3. If you don't remember factoring from last year, it is going to come up this year. Not a ton, but it is going to come up. Then once we do this, we make our little wall there to set each one of these equal to 0. This is where we use something called the zero products law. So if we add 8 to both sides, we get x equals 8, which is my answer. And we get x equals negative 3, which is totally an answer in algebra, but not in geometry. We don't want negatives. That's just no good for us. It then says to find a measure of angle ABC. So ABC is going to be 8 squared, so that's going to be 64 degrees. All right, let's take a look at the homework. Homework's just a couple questions, not too bad, right? First few here involve the auxiliary line concept. So if we take our straight edge and make a auxiliary line here, I know that line's going to be parallel to the other two. So this angle of 130 is on the same side as this piece here, so there are going to be supplements making this 50. Well, if that's 50, the other angle must be 46 to make the whole angle of 96. And then that angle of 46 and this angle of 1, well, they're alternate interior, so they're the same size. Same thing for 2. If I extend the parallel lines and draw it on our auxiliary line, look at that. If that's 129, I know that this angle is also 129. The part of angle 2 is on the same side as the 129, so they are supplements to each other. So that makes 51. I see this is 117, so this angle is 117. I know that the part of angle 2 on that side is the supplement of 117, so that would be 63. Therefore, angle 2 is 63 plus 51, or angle 2 is equal to whatever that comes out to be, 114 degrees. Almost done. Let's look at 3. Parallel lines, alternate interior angles here to here. I see a triangle. Triangles have angles that add up to 180. So 180 minus 37 minus 44. So whatever that comes out to be, we get 99. So 99 is the third angle of that triangle. I then see a linear pair here. So if I do 180 minus 99, I wind up getting 81. So angle 3 is 81 degrees. The diagram for 4 is kind of challenging because of the lines, but if you just extend this one, it makes a little bit more sense, right? We now see our transversal. So I know that angle is 78, therefore this angle is 78. And this angle must be 102 because they are a linear pair, they're supplements. Well, if that angle is 102 by vertical angles, this angle is 102. And then I know that that triangle has 3 angles that add up to 180. So if I subtract the 102 and the 48, I get 30. Therefore, angle 4 is 30 degrees. And the last one, number 5, is almost exactly like, let me show you, number 6, just with different numbers. So if you're confused about 5, follow the video or go back to the example from class, either way. So this question is explaining something about angle A and angle B, but this time it's not giving us anything about angle C. So I'm going to let angle C just be C. Angle A is going to be 2 times C minus 3. And angle B is going to be C plus 11. Now, just like we did in the lesson, we know that each of these angles together becomes a total of 180. So now I have 4C plus 8 equals 180. Subtract 8, and I have 4C equals 172. Divide 172 by 4, and we get 43, which tells us one of my angles right away. Angle C is 43 degrees. To find angle A, I would do 2 times 43 minus 3, so that's going to be 83 degrees for angle A. And angle C is just going to be 43 plus 11, so angle B is going to be 54 degrees. Quick check, those 3 angles add to 180, so we are all set. I'm hoping this video helps. If you have to watch it once or twice, pause it, rewind it, whatever you got to do to figure this lesson out would be beneficial to you. Because we are moving on tomorrow to lesson number 11. And I'm sorry, lesson number 10. I just noticed there's one more question in the homework. Oh geez, let's look at this one. So for this question, it says, in the following diagram, triangle ABC has been drawn, and line segment BC has been extended to point D. So we have all these angles. It says, what allows us to draw segment CE? So what allows us to draw segment CE is the fact that these 2 angles, right? So if AB and CE are parallel to each other, that means angle 1 and angle 4 must be congruent, because they would be alternate interior angles. That's basically the same question in part B. So number 4 is congruent to angle 1, right? There are other angles here that are going to be congruent. If you look, angle 2 is going to be the same as angle 5. Those are corresponding. That's part C. And the last part, explain how we can conclude angle 1 plus angle 2 plus angle 3 is 180. Well, if you look, angle 1 and angle 4 are the same, angle 2 and angle 5 are the same, and angle 3 is the same both in the triangle and in this one straight line here. Therefore, they have to add up to 180, right? So angle 3 plus angle 4 plus angle 5 makes 180 because it's a straight line. And I know that angle 1 is the same as angle 4, and angle 2 is the same as angle 5. Therefore, I could substitute them back in and say that that's the same. If you understand this question, you actually truly understand the reason why triangles add up to 180. If you don't, it's not like a huge deal, but it is kind of a nice little concept here. All right, so that's the end of the video. Hopefully you watched all the way to the end. All right, like I was saying before, if you have to pause it, rewind it, use it however you need to be able to understand this lesson. Good luck.